Now we will run a paired t-test on our sample data. So here's the data, our study that we were referring to. We have our 10 participants and we have their pre-test and post-test scores. Let's take a look at the variable view real quickly just so you can see how that's formatted. So name is there with string. We have that as our nominal variable, and then we have pre-test and post-test. Notice that there is nothing in the values column because we don't have any categories. We don't, because this is not categorical data. All right, so the first thing we're going to do, we're going to begin by selecting transform and then compute variable. This will take us to the compute variable menu, and so we want to enter diff in the target variable box. And we're going to enter post-test minus pre-test in the numeric expression box. So this is telling us that our diff variable equals post-test minus pre-test. And then we're going to click OK to process this menu. All right, so let's go back to our data set, and now we can see our new column here. So column 1 is name, column 2 and 3 pre-test, post-test. Sorry, 1 is name, 2 and 3, and then 4 contains the diff variable. So it was created just as we specified. Diff equals post-test minus pre-test. It is now time to generate the histogram with the normal curve for the diff variable, and so we are going to do that next. So there, as you probably remember, there's different ways that we can create a histogram. You can go into graphs to create a histogram. You can go into analyze descriptive statistics to create a histogram. And so any way that you would like to do that, you can go ahead and do that. And so we're going to go ahead and do it from analyze descriptive statistics, frequencies, and here is our frequency menu. We're going to move diff over from the left window to the right window. We're going to click on charts. We're going to click on histogram, and we also want to show the normal curve on the histogram. Then we will click OK. This will bring us back to the frequencies menu, and then we're going to click OK again, and this will tell SPSS to create a histogram with our normal curve for diff. And here is our histogram with our normal curve. Looks pretty good. Looks pretty good. I would say that it presents a reasonably symmetrical bell shape. And so we can say that the difference between the pre-test and post-test scores meet the criteria of normality. So let's go back to our main screen to run the paired t-test. Let's click on Analyze, Compare Means. This time we're going to click on Paired Sample t-test. So now we want to copy the pre-test variable over from the left window to the right window. That's going to be our variable 1. Then we're going to copy post-test from the left to the right, and that's going to be under variable 2. And now we will click OK. And we can go ahead and leave estimate effect sizes. Okay, so the results of the paired t-test are read from two tables. We have our paired sample statistics test that reports the means for each group. We have our pretest mean 36.4, our post-test mean at 40. We have our sample size of 10 for both groups, and here's our standard deviation and our standard error mean. So, and then we have our paired samples test right here. This table focuses on the difference between the pretest and post-test scores. Column 2 shows that there is a negative 3.7 point difference between the means, between those mean scores, between 36.4, if we say 36.4 minus 40.10, it's going to be a difference of a negative 3.7. And our last column here is our significance value, and it shows that our p-value here is 0.030, and for this comparison, since 0.03 is less than the specified alpha level of 0.05, we can conclude that there is a statistically significant difference between the pretest and post-test scores. So that is how you run a pair t-test, and that is our output that we examined and interpreted. I hope this video has been helpful.